Hello, good morning. Good morning. You all there? Those who are here, please say good morning. Okay, right. Okay, only 6 members. Okay, I just waited. Okay, then I entered. Dhanush was there, then later left and then joined. Okay, right. Okay, so let's just proceed now. So good morning, everyone. So is it the PPT visible to you now?
Yes, sir, we can see.
So yesterday we have started with the microprocessor and microcontroller, which is the second component of your mechatronics system. Okay, apart from the sensors and the actuators, right? Okay. Now we are done with in the first class. Okay, we are done with the formal structure of a microprocessor. We understood what do you mean by microprocessor. Formal structure of a microprocessor we understood. In the formal structure of microprocessor, we understood there is something called as a microprocessor. Under the microprocessor, we will be having arithmetic logic unit and then register array and then the timing and control unit. Okay, those are the three components which are going to be present. And then the second the component was the IO devices, okay, which is nothing but your the peripherals, okay. And third component was called as the memory. And all these three components are going to be connected through a communication channel that is called as the bus, okay. So we have discussed some different types of hello.
Yes, sir.
Hello?
Yes, sir.
Sorry.
Yes, sir. We
Okay.
can hear you, sir.
Some problem has occurred with the system. Okay, sorry about it. Right. Okay. Right. Now, I think I was discussing about the three formal structure of the microprocessor. Okay. After the three formal structure, okay, which was connected by the bus, then we have started with the 8085 microprocessor architecture. Please mark this as important from the exam point of view. Okay. Right. Just note down this is what is the block diagram, which is about the 8085 microprocessor architecture. Okay. Now I will just try to discuss one by one in detail. Now I think this is what I have done in the last class. So basically, the internal structure of 8085 is used for these purposes to store 8-bit data, to perform arithmetic and logic operations, which is done by the arithmetic logic unit. Then it is going to be used to sequence the execution of instruction, which is done by the timing and control unit. And we have a memory, which is going to be used to store the data. Okay, right? So RAM and also there's one more memory, the ROM. Okay, now one by one we'll finish. Now the first element we'll discuss is called as your arithmetic logic unit. So basically, ALU performs what? Okay, ALU performs the mathematical and the logical functions. Okay, now all the computational activities of your microprocessor is going to be done by using what is called as the arithmetic logic functions. Okay, right. Then next is going to be what is called as your the temporary storage cells. Okay, that is called as a temporary storage data. That is going to be done by what is called temporary registers. Okay, basically temporary registers are the one which are going to be used to store the intermittent data, which is flowing into the microprocessor and which flows out of the microprocessor. Okay, right. Then the results of any of the operation, okay, immediately after the ALU performs the operation, then the result of those operation is going to be stored in what is called as an accumulator. Okay, basically it's an 8-bit register which is going to be used to store the results of any operation. Okay, maybe for arithmetic operation or for a logic operation. Therefore, the data, the output of arithmetic logic unit will be stored where? Will be stored in the accumulator before it is being sent to the other details. Okay, right. Then the instruction decoder is going to be there. Basically, instruction decoder decodes the instruction from the instruction register and activates the timing and control unit. Okay, now before the instruction, if you observe, before you fetch the instruction from the bus, okay, so to give it to the timing and control unit, because timing and control unit is used for this particular operation. If you remember, timing and control unit is used for sequencing the execution of instruction. Okay, as the timing and control unit is used for sequence the execution of instruction, now this has to be activated. The timing and control unit has to be activated. Okay, in order to make this to active, okay, now the instruction decoder will fetch the instruction from the instruction register. Okay, instruction register is the place where the instruction of the program, one of the instruction of the program is going to be stored. You are going to take the instruction from the instruction register and converts it into an understandable machine level language by the microprocessor, and it gives it to timing and control unit for the purpose of execution. Okay, so that is the flow of instruction register and instruction decoder. Okay, right. Then we have next, as I said, the decoder decodes the instruction from the instruction register and activates the timing and control unit. Okay, now next should be the timing and control unit. Okay, what for it is used is basically, as I said earlier, the timing and control unit is going to be used to determine the timing and sequence of operation. Okay, it is going to be used to determine the timing and sequence of operations. Okay, now in at what time the operation has to be done and what is the sequence of operations. Okay, right. Now it generates the timing signal used to fetch the program instruction. That means now in order to make the timing, okay, please understand, the microprocessor is what? Microprocessor is a clock-driven electronic device. Okay, right? The microprocessor is a clock-driven electronic device. So now, in order to fetch the information, information regarding the program, now the timing and control unit has to generate the timing signal. Okay, now based on the timing signal, okay, so based on the timing signal generated from the timing and control unit, the execution of the program and the sequence of the program is going to occur. Okay, right. Now this is the one, okay, timing and control unit is the one, okay, which controls the entire operations of a microprocessor system. The whole of the operation of a microprocessor system is going to be controlled by timing and control unit. Okay, right. Then we have what are called a general purpose register. So basically, when you say about general purpose register, okay, so all these registers are going to be of a 8-bit case only. Okay, so these are called as 8-bit register. So now, if I'm going to use it as a 8-bit registers to store the intermediate data, the name of the registers are going to be B, C, D, E, H, and L. Okay, so these are the individual 8-bit registers which are going to be present. Okay, but they can also be used in combination. So when I use in combination, it is going to be used to handle 16-bit data. So the combination of the valid combination of the registers are going to be BC, okay, and then DE, and then what is called as the HL. Okay, so BC and DE is used for the data, and HL is going to be used for addressing the memory. Okay, please remember HL register is going to be used for the addressing the memory. Okay, right. Then we have what is called as a PC register. Okay, that is called as program counter register. Okay, now the program counter register, okay, is going to be something like this. Okay, now just if I am going to have the program written here, okay, just assume this is one line, second, third, fourth, something like this. Just assume these lines are going to be the program, the instruction numbers. Okay, right. Now the program counter register, okay, is going to be something like this. Okay, so this is a program counter register. Okay, so as I said, it is going to be 8-bit register. So assume that we have 8 different boxes here. Okay, so all these boxes should be filled with either 0 or 1, that is known to you. Okay, now what is the content of the program register is important. Okay, now as I said, so he says program PC register is used to control the sequencing of the execution of instructions. Okay, right. Now mainly, now assume that at this point of time, okay, at this point of time, we have this particular line, the first one. Okay, now just for the clarity, I will go with only 4 bits. Okay, now the address of the first line is going to be 0110. Okay, just imagine. Okay, now it's a 8-bit register only. Now to reduce the time, to minimize the time, just for the clarity, I am using only 4-bit register. Okay, the first instruction, the memory of the first instruction, the what do you call as your the data, okay, is going to be 0110. The address, second address is going to be 1110. Just assume. So these are called as the addresses of the memory locations of the instructions. Okay, so in the instruction register, in the first box, this is the information. The second box, this is the information. Okay, currently microprocessor is executing the first instruction. Okay, please understand, currently the microprocessor is executing the first instruction. At this moment, the program register is going to have what is called as the data 0110. Okay, now you know that it is going to be written from LSB to MSB, that is least significant bit to the most significant bit. Now please observe, now what is that program counter register instruct the address I am having? What is this address says to you? What is this address says to you? Sorry. It is not 0110. So 0110 is already going on. Okay, sorry. How do I erase it? Okay, right. Sorry. Okay, so sorry. So 0110. Okay, right. Now to start with, okay, let me put this way. To start with the operation. Okay, now the microprocessor has not started the operation at all. Just assume microprocessor has not started the operation. At that moment, what is the content of the program counter register? The content of the program counter register is the address of the first instruction. Okay, please remember, the content of the program counter register is the address of the first instruction that you are going to start. Now generally, the program counter register is going to have the address of the next instruction to be executed. Please listen, the PC register is going to have the address of the next instruction to be executed. Therefore, in the initial, to start with, okay, I not started to execute. Therefore, what is the address of the PC register to start with? Before execution, What is the address of the PC register? Is it this one or first one or the second one? To start with. Okay. Right. Now, I'll like to make it. Okay. So assume this is going to be a 4-bit register. Okay. So 4-bit, I'm just taking 4-bit actually. Okay. So PC. Now at an instant of time. Okay. So I'm just redrawing. Okay. Right. This is the first instruction 0010. Okay. Right. Then next is 1110. Okay. Right. Now at a particular instant of time, this is already been done. Okay. That is the instruction of 0010 has already been taken care. Therefore, in the program counter register, if you observe, this register always holds the memory address of the instruction that will be executed in the next step. Okay, right. Now, the first instruction is right now it is going on by the microprocessor. Therefore, the program counter register is going to have the instruction like 111110. Okay, means what is the understanding? If you are going to observe this, if you are going to observe the program counter register, you will be knowing what is the next instruction that you are going to execute. Okay, now by observing because though then assume that there are going to be 100-line program that is going to be there. Now you want to have a track. Okay, you want to know the track of the program. Okay, where your program is currently been executing. So therefore, if you observe the program counter register, the address of the program counter register says about what is the next instruction that you are going to execute. Okay, so that is the concept of what is called as the program counter register. Okay, then next we have what is called as a stack pointer register. Okay, in case of a stack pointer register, it is similar to this. Okay, we have what is called as the random access memory, which is going to be present. Okay, now again, now all memory is going to be what is going to be divided into some sections. Okay, so all these are going to be called as the individual stack. All these are represented by the address. Okay, so 0110. Okay, 11. Okay, right. 000 something like this. Okay, just an example, 2-bit I have taken. Okay, right. Now these are the only possibility. If I'm going to have only 2-bit, so only possibility is for different content. Okay, now stack pointer register. Okay, if I'm going to call this as a stack, sorry, this is a stack pointer register. Okay, so I took only 2-bit, so I just divide it into 2. Okay, so stack pointer register forms an address which defines the top of the stack in RAM. Okay, right. Now this is the RAM. Okay, which is having the top stack is going to be this. The top stack is having the address what? The top stack is having the address 0 and 1. That is going to be present in what is called as your stack pointer register. Okay, so stack pointer register is going to form an address which defines the top of the stack in RAM. Okay, so the RAM is going to have so many memory locations are going to be there. Okay, out of so many memory location, the address of the top location, is going to be stored in what is called as the stack pointer register. This is also called as the SP register. Okay, right? Are you understanding? Hello?
Yes, sir.
Okay, can you able to get? Okay, right. So that's about the
Yes, sir.
that is about the stack pointer register. Okay, so program counter register, the content of the program counter register is the address of the next instruction. Okay, the content of the program counter register is the address of the next instruction. The content of the stack pointer register is the address of the top of the stack in the RAM. Okay, it's going to consist of the address of the top of the stack in RAM. Okay, right. Then next is going to be what is called as SID and SOD. SID is nothing but serial input data, and SOD is the serial output data. That is, now any data which is into the microprocessor. Okay, any data which is going into the microprocessor is going to gone through SID. and outputted through the microprocessor through what is called a serial output data. Okay, right. Next we have one more important component called as the bus. Okay. Now, as I said earlier, the bus is mainly used for what? The bus is mainly used for communicating signal among the devices. Okay, so we have various different devices, as we have mentioned now. All those devices are going to be connected through what is called as a bus. Okay, right. Now, if you observe, so basically there are three different types of the bus are going to be present. Okay, in 8085 microprocessor. So we have the data bus, which is of 8-bit. Okay, so it is a bidirectional, means you can take the data from the microprocessor and you can give the data to the microprocessor. That is, SID is also going to be used and SOD is also going to be used. Okay, right. Now in the address bus, okay, so I am taking the address only from the microprocessor. Okay, the addresses are already stored in the microprocessor memory. Okay, so there is nothing to nothing to store as in the form of the address. Now all those addresses, okay, are going to be fetched from the microprocessor. Hence, the address bus is going to be a unidirectional data communication. Okay, and control bus is mainly used to control the execution of the program, which is the case of timing and control unit. Okay, so that's again it's going to be bidirectional entity. Okay, right. Now very briefly we'll just make it out. Okay, the address bus, it consists of 16 address lines. Okay, so A0 to A15. Okay, when I'm going to say 16 address line, so the total number of memory locations it can able to address. Okay, the address bus of 8085, the address bus of 8085 can able to address the memory locations equal to 2 to the power of n. Okay, where n is the number of address lines. Okay, now here in case of address bus we have totally 16 different address lines. So considering the fact that we have 16 address lines, now you can go with what? 2 to power 16. Okay, so 2 to power 16. So 65,536. That is 64 into 1024. 64 K memory location. So basically, so this is the total locations that you can able to address. Okay, you can just imagine it's a very smallest of a kind. Okay, way back it is way back is the case of 8085 microprocessor, right? So now this is basically operates in a unidirectional mode. Okay, the address bits are always sent from the microprocessor to the peripheral devices and not reverse. Okay, so we are going to fetch the address from the microprocessor, nor we are not going to give the address to the microprocessor. Okay, right. So this is about the case of address bus. Then we have a data bus. Okay, so data bus consists of 8 different lines, that is D0 to D7. But through this D0 to D7 you can communicate into the microprocessor and you can take the information out of the microprocessor also. Okay, it is, as I said, it operates in bidirectional mode. Okay, it's a bidirectional bus. The data bits are sent from the microprocessor to the peripheral devices as well as from the peripheral devices to the microprocessor. That means you are going to input the data. When you are inputting the data through your the input devices, you are actually inputting the data to the microprocessor. That means that data will go through the microprocessor. Okay, sorry, it goes through the data bus into the microprocessor. That is one-way communication. So within the microprocessor, assume you are doing some mathematical operations. Okay, so you want that results to be given to the output devices. Let's say a CRT or to the LED display. Okay, so ALU does that operation, and immediately after the ALU, accumulator is going to store that information. Then that output, whichever is stored in the accumulator, will be passes through the serial output device through the data bus. Therefore, the data will go into the processor, and the computational data or the computed data will be going from the microprocessor to the outside world. Okay, therefore, it should be a case of bidirectional. Okay, then the control bus. So it consists of various lines carrying the control signals. Okay, so control signal is read signal, write signal, and the something like flag bits that you will be understanding bit later. Okay, so this control bus is again it's going to be a bidirectional information flow. Okay, so that's about the bus. Then we have what is called as the flag register. Okay, so the flag register is nothing but it indicates the results of mathematical operation. Okay, basically the flag is nothing but after the operation. Okay, just let me explain. Okay, so the first thing is it indicates the result of mathematical operation. Okay, now once you have done a mathematical operation, the output of the mathematical operation will give some data. Okay, let's say. Okay, right. Now the output of the mathematical operation might be a positive value or a negative value. Okay, now how do we know? Okay, so that is nothing but sign flag. Means the flag register is a special purpose register and is completely different from the other register in a microprocessor. Okay, right. Just don't worry about that. The flag register is going to have 8-bit. Okay, and only 5 of them are useful in 8085. Okay, it means to say that. Okay, so you have, this is, if I consider 1, 2, 3, 4, 5, 6, 7, 8. Okay, right. Now in this case, only 5 bits are going to be present. Okay, let's say from 5. Okay, now 1, 2. Okay, some we'll discuss in detail. We'll discuss, but as of now, just observe. Okay, so one is called the sign flag. Okay, so sign flag. If we assume this is a sign flag, this is the S flag. What is the content of this? It can have which number? Sign. If I assume this is a sign flag, which number I can enter here? Can I enter 2, 3, 4, 5, 6? Which are the possible numbers here? Huh? Please tell me. Okay, so this is a sign flag. This is your register. This register should have some number. Okay, okay, and in each of the bit. Okay, microprocessor stores what type of number system? Come on, microprocessor stores what number system? Microprocessor.
Binary.
Simple. Microprocessor stores a binary number system. That's all. Okay. Therefore, in this sign bit, which number can be present? Either
0 or 1.
simple, either 0 or 1. Okay. Now, sign bit may have a possibility of having 0 or possibility of 1. Now, if this is going to be a sign flag, okay. Now, if the sign flag, okay, if the sign flag shows if the flag shows 0, I am going to say it's a positive number. If the sign flag is 1, I am going to say it's a negative number. Means to say, what I mean to say is, if you observe this particular flag register, if you observe this assigned bit for the sign, by knowing whether it is 0 or 1, you can understand whether the operation just now finished has given you the positive value or a negative value. Okay, like that. There are many operations are there. That is sign flag, 0 flag, auxiliary carry flag, parity flag, carry flag, something like that. Okay. So in detail, you're going to discuss. But remember, the results of the mathematical operation, okay, is going to be stored in what is called as the flag register. Okay. So there are totally 5 different flags are going to be present. Okay. These flags should have either have 0 or 1 as the data. Okay. So right. Then next is interrupt control unit. Okay, so this is another component architecture of a microprocessor. Interrupt control unit, very important. Now, is this the 8085 facilitates interrupt service by providing 5 sets of dedicated interrupt lines. Okay, some interrupt lines are going to be present. So we call those interrupt lines as INTR. Okay, INTR is nothing but interrupt. Okay, then restart terminals. Okay, RST is restart terminals, RST 7.5, 6.5, 5.5, and something called as trap. Okay, so these are the 5 different interrupt lines which are going to be present. Okay, now in detail I'll discuss later, but just remember, interrupt is something but now if you consider this as your microprocessor, okay, so which is doing some task. Okay, so microprocessor is doing some assigned task. Okay, so it is actually carrying out some assigned task. It is busy in doing its own task. Okay, now during this you have one more signal which has to be attended by the microprocessor. Okay, which is more prominent than your the current work. Therefore, what I will do, there is one signal which is generated. Okay, which is more important. This is more important signal. Okay, now currently what is this? Currently what is happening? Currently the microprocessor is busy in doing its own job. Okay, so microprocessor is busy in doing its own job. Now through the interrupt line, okay, there is something called as interrupt line here. Okay, through this 5 different dedicated interrupt line. So through this, you send the microprocessor that somebody wants the attention of the microprocessor. Okay, I hope you're understanding. Okay, now you say that somebody wants the attention of the microprocessor. Okay, when the microprocessor has received okay information that when somebody wants the attention of the microprocessor, then it is for the microprocessor to decide okay whether it has to give the attention or not. Okay, so that is how the interrupt that's how the interrupt is going to be taken care. Okay, right. That means interrupt is nothing but basically the understanding is once again. ಅವ್ರಿಗೆ ಹೇಳು ಕೃಷ್ಣಪ್ಪನಿಗೆ ಡೈಲಿ ನೆಕ್ಸ್ಟ್ ಡೇ ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ತಾ ಇದೆಯಾ ಕೃಷ್ಣಪ್ಪನಿಗೆ ಡೈಲಿ ನೆಕ್ಸ್ಟ್ ಡೇ ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ತಾ ಇದೆಯಾ ಅಂತ ಹೇಳೋದು. Right, okay, right. Now when the interrupt line is just okay, sorry, okay, right. Now when the interrupt is going to be there, interrupt is nothing but what? You are disturbing, simple, okay, simple. Interrupt is nothing but you are disturbing the process of the microprocessor. Okay, now just now an interruption has occurred like that. Okay, I was doing some task. Okay, just a simple example for understanding. I was doing some task, some interrupt has occurred. Now I felt that has to be signed now, okay, immediately the attendance. So that is a concept of an interrupt. So in the same way, now in the microprocessor, when the microprocessor is carrying its regular task, some interruption is going to come, some request for the interrupt is going to come, which is sent through the interrupt line. Now it is for the microprocessor to decide to attend to it or not to attend to it. If it is required to attend, what it has to do? Temporarily, it has to suspend this, then go and attend to this important task, complete this, and come back to this main task and continue the operation. Okay, now this is how it is going to be. That is called as an interrupt control unit. Okay, right. Then next we have last one called as your address and address data buffers, are the ports where the addresses and data are going to be placed. Okay, now through this you are going to send the information. Okay, right. Now this is about what is called as the architecture. Okay, right. Now just in summary, please observe, right. So we have started with what was called as arithmetic logic unit. Now in the exam, what you have to write is briefly you are supposed to write maximum marks for this is 12 marks. Okay, with any diagram explain the architecture of microprocessor. Okay, maybe for 10 to 12 marks it is going to be there. Right, briefly. Okay, in the test also you are going to get this for 6 marks. Okay, most likely. Right, now an important question. Okay, as I said earlier. Okay, right. Now so briefly, arithmetic logic unit. Okay, so it does the mathematical and the logic function. Then we have temporary registers, okay, which are going to be used to store the data. Accumulator is going to be used to store the data obtained from the arithmetic logic unit. Then flag registers are going to be present, okay, which are going to be used for the purpose of knowing what is the output of the signal. Then you have instruction register storing the addresses of the instruction. Instruction decoder decodes the instructions and give it to the timing and control unit. Timing and control unit is the one which controls the whole of the activities of the microprocessor. All these are going to be run through what is called as the bus. Okay, so as I said, so we have different buses, so like data bus, address bus, and control bus are going to be present. Okay, then you have a general purpose register. So these three, this is called a general purpose register, which is B, C, D, E, H, and L. Okay, then we have what is called a stack pointer register. This is your SP register, which the stack pointer register is going to consist of the address of the top stack of the RAM. Okay, please remember, stack pointer register consists of the address of the top stack of the RAM. The program counter register, so is PC register, is going to consist of the address of the next instruction to be executed. Okay, right. Then incrementer and decrementer is going to be used to go for the next line of the program. Okay, then all those addresses and data are going to be stored in an entity called as address buffer. Then SID and SOD, as I said, the data will input through SID and the data will goes out through the SOD. Then the last one was the interrupt control unit, which is going to be used to drag the attention of the microprocessor while microprocessor is doing the main task. Okay, if something important is going to be required, then a microprocessor will attend to that particular interrupt. Okay, so that is the case of this is the architecture. Okay, now this is one part of the content. Okay, that is directly we have explained about the architecture in brief. Now, okay, after understanding this architecture, okay, now we'll go with the microprocessor architecture terminologies. Okay, why I am taking this separately is now individually this might also be asked. Okay, right? So individually the architecture might also be asked for 8 to 10 marks. Okay, so in that case you may have to write more than what you have wrote in the architecture. Okay, in the previous section, broadly you are going to write what is the components of the microprocessor. Now in detail you are going to discuss. Okay, right. Now one by one we'll finish it off. So first one is central processing unit, that is CPU. Okay. Now basically, as we understood that the CPU is the processing element. Okay, the CPU is the processing element. Now under the discussion, what we are making, the microprocessor 8085. The microprocessor 8085 itself is what is called as the microprocessor. Okay, is the CPU. Okay. Now it recognizes and carry out program instructions. So this is the one which processes the data, fetching the instruction from memory, decoding them, and executing them. Okay, so this is basically the work of what is called as the central processing unit. Okay, right. Now, after it has performed the operations basically, then we'll be having something called as memory and address. Okay, right? We have what is called as a memory and address. So basically, a memory is nothing but what? Okay, memory is a physical device where the programs are going to be stored. The physical device where all the instructions are going to be stored. Now, as I said, so this memory is going to consist of so many locations. Okay, and in each location, observe. Okay, you have what is called as a memory. Okay, memory is a location. In each location, so you are going to store the data. Then how are you going to identify that data? Okay, so there are so many houses are going to be there. Now each house is going to be uniquely identified. Okay, let me assume like this. Okay, there are so many houses present. So each house has to be identified. So this identification is going to be done by what is called as a unique address. Okay, like that. So in there are a good number of memory locations are there. If I consider 8085 only, so the total number of memory locations are going to be 2 to the power of 16. So 2 to the power of 16. So it is 65,536. That is 64K is the number of memory locations which are going to be present. So how do I understand those locations is going to be through what is called as a unique number, which is called as the address. Therefore, the memory is a physical device where programs are stored. The memory device contains many memory locations. Okay, right? Then each location is defined in terms of an address. Okay, and which is nothing but the unique number. Okay, right? Then it's just just a simple diagram to say about the memory. Okay. Now this is what is the structure of a memory. It's going to be, now assume it's going to be a microprocessor chip, and you have a memory locations here. Okay. So this memory location, I took something, and these are all the various locations. Okay. So like this, you will be having what is called as 64 into 1024. Okay. So you have 64K. Right. So all these memory, there are so many memory locations are there. Each memory locations are going to be identified by what is called as a unique number. Okay, which is nothing but your combination of zeros and one. That is a binary addresses are going to be present. Some addresses are going to be present here. Now in this case, as I said, it consists of the memory elements. Okay, basically it consists of a large number of storage cells. Okay, as I said, with each cell capable of storing either zeros or ones, and it is identified by these storage cells are called as the locations. Okay, and in order to access these memory locations, okay, I am going to have what is called as a unique address. Okay, right. Now if you just proceed further, now to this the memory. Okay, you know very clearly that you are going to store the data, and also you are going to retrieve the data. Okay, so therefore what should go into this memory is going to be the data line should pass. Once I say data line, so bidirectional. Okay, you are going to send the information and retrieve. and also address lines. Okay, means all these address lines are going to be present. Okay, now therefore it is unidirectional. Okay, in the initial stage, you wrote the addresses for all this location, so that is done by using your address line. Okay, and then we have the microprocessor can store and retrieve the data in the form of memory. Okay, the microprocessor can store and retrieve the data in the form of memory. Okay, and when the microprocessor needs data from a specific location, it sends the address to the memory over the address path. Okay, now just observe. Now I want to fetch the information which is present here. Let me say, okay, I want to fetch the information which is present here. Okay, in order to take this information, how do I send the data? Now through the address line. Okay, observe, we have the address line. So through the address line, I have some the address of this. Okay, the address of this, let us say, okay, 5H. Okay, what is this address means? Okay, so a simple example I have given, 5H. Okay, so H is your hexadecimal, 5 is your decimal. Okay, some information is present here. Okay, 5H is not the information, 5H is the address. Now through this address line, I am going to send this information. Okay, so through this, I am going to send this information. Then this is only one way of the data. Please understand. I am sending the address through the address line. So this 5H will go and search in everywhere. Okay, search here. Okay, so I will search everywhere, seeking for or checking for where my FH is going to be present. Okay, now when I send this, so the some match somewhere the match is going to be there. So the match has occurred here. Now I can able to know what is present in this 5H. Okay, in this 5H, some information is going to be stored in the form of the binary. Let's say something like this. Okay, so it is 8-bit information, 1 2 3 4 5 6 7 8. Okay, so this is present. Now this information I am going to retrieve. Okay, once I retrieve this information, so this information will it flow through the address line or data line? Will this information flows through the address line or data line? Through what it is going to flow through? So this is the information which is present in one of the memory location. This is the information which is present in one of the memory location. I am retrieving the information. When I am retrieving the information, so this will go through what is called as the data line. Okay, so this is bidirectional. Okay, you can't send it through the address line because address line is only unidirectional. Okay, it can send only the address to the microprocessor. From the microprocessor, it can't take anything. Okay, right. So when the microprocessor needs data from a specific location, it sends the address to the memory over the address path. That is what I have explained. It sends the address through the memory over the address path. It checks that particular location, takes that information, gathers that information, retrieve that information present in that particular address, and then it will be sent back to the data line. Okay, right. Now just observe. You can read back. The decoder circuit within the memory device decodes the address in order to select a specific location. The data is read and sent back to the microprocessor. Okay. So now the memory chip must have a data path and the address path. The data path is bidirectional and address path is unidirectional. Okay. So we have discussed this already. Then VCC is the DC supply signal. Now these are the signals which are going to be present. Okay. VCC is the DC supply signal. VSS is the ground terminal. RD is for read operation and WR is for write operation. That means now if you observe here, we have these two, the voltage control levels. Don't worry about that. VCC or supply signal, VSS is the ground. Now we have three operations here, three signals which are there: RD, CE, and WR. Okay, RD is used for reading the information. Okay, RD signal, when this RD signal is flagged, I should understand that the memory is used for reading the information. Okay. Now, if WR is going to be there, I am writing something onto the memory. Okay. When RD is going to be there, I am reading and retrieving the information. When WR is going to be there, I should understand that I am writing some information into the memory location of into the location of your memory device. Okay. Then C is going to be used, that is chip enable is going to be used as to be given for chip selection. Okay. Now when I say chip enable, so either it's going to be means to switch over between RD and WR signal is going to be present. Okay, right. Now you have to select either the RD signal or WR signal through a chip enable signal, okay, which is going to be used to switch back and forth between RD and WR. Okay, right. Then so last one, okay, we have the different forms of the memory which are going to be there. Okay, that is one is called as your the read-only memory. Okay, we can understand the ROM. Okay, ROM is only for the purpose of reading. Okay, so subsequent erasing is not going to be possible in that particular case. In read-only memory, it's a permanent storage of data. Okay, when sudden switch off, when sudden the current fluctuation or switch off is going to occur, the content of the ROM will not going to be changed. Okay, that is known to you. Okay, ROM will the content will stay as it is. Okay, and then we'll think we'll stop at this stage. Okay, right? We'll stop at this stage, and I will continue this the explanation in the next class. Okay, right. So before we go further, we'll okay, we'll quickly take the attendance of today's class, and then we'll finish. Okay, Khalid Pasha, Abdul Khalid, Anil Kumar Wester. Are you type your user number? No issue. Okay, all of you type your user number. I will take from there itself. No problem. Okay, right. So all of you take your user number. Sorry, type your user number in the chat box. Okay. So there are 30 members, excluding me 28. Okay. So type the user numbers and I'll take from there. Okay.